Okay, here's a little simulation from the University of Colorado. And I'll enable the speaker right here where it says audio enabled, and we're going to experience it as the listener. I'll turn down the amplitude before I hit play so it's not piercing your ears, and you should be able to hear it. Alright, and then now if you notice here, there is a little, I forget what to call this, a slide bar or whatever, a little slide that will increase the frequency. So right now it's at a low frequency. I just turned it down so you can hear that at a very low tone. And then now if I increase the frequency, we have to wait for it to strike your ear, and you should be able to hear the high pitch, right? I can go even higher. It has to reach your ear, and it goes even higher. And then if I go lower to a lower frequency, it goes to a low pitch, and you can see the pictures of the waves. So the higher the frequency, there are more waves per second. The lower the frequency, the fewer waves per second. And then of course then there's amplitude. So if I increase the amplitude, then the sound waves are going to become more intense and be louder. So you can see the change of color there, showing that the waves are more intense and the sound is much louder. All right, let me pause it. Another part of what the unit talks about is something called interference. So if we have two waves or two speakers sending two sets of waves, let me increase the amplitude a little bit. Let's see here. Whoops, I don't hear anything. There we go. Let me turn down the amplitude a little bit. It's a little loud. All right. So you see the two waves interfering with one another. So you see a set of waves from the upper speaker and a set of waves from the lower speaker. And when the waves interact, there will be places where the waves combine, and then there are places where the waves interfere with one another, where they cancel each other out. And the way to show that is I'm going to move the little guy here, and I can move him to a place where the sound disappears. So in this spot, there's barely any sound because the two waves are canceling each other out. That means a crest is matching up with the trough of the other. And so the two waves has a high point and a low point meeting at the same time, and so they cancel each other out, and you get like a flat line. So let's see if I can, like, here, right there, there's practically no sound at all. So that's an example of wave interference. All right, and that's or specifically destructive interference, where the two waves cancel each other out. And then here is an instance where the waves are constructive, where it's actually louder, where it's crest with another crest, where the two waves are the crests are matched with the crest of the other, and the trough of one is matched with the trough of the other. So the sound is actually louder than it would be if there were just one speaker. All right. So I wanted to show you that. I have another video that really shows and gives you an example of how waves have destructive interference. So again, if I move the little guy here, he doesn't hear anything. And if I move him up, he hears it much louder. Okay. All right, we're coming up on 5 minutes. All right, hope that helped you with the lesson.